So what we're going to do today is we're going to take a given sequence and we're going to figure out the nth term. We're going to figure out the general term. And I'm going to try to give you some tips, give you some guidance, and then I'm going to have you try to figure some of them out. The first one, actually, before we even start, you want to think about which term it is, because that would be the n, that's going to be the variable. So this is the first term, this is the second term, third term, fourth term, fifth term. So what I'm going to do is I'm going to plug in 1 into an equation and get out 2. I'm going to plug in 2 and get out 4. I'm going to plug in 3 and get out 6. I'm going to plug in 4 and get out 8. Do you know what the pattern is?
Times 2.
I'm going to take the term number and multiply by 2. So we're going to say a sub n equals 2 multiplied by n. N is the term number. Right? Now I want to show you something right here. If we actually looked at the differences between these numbers, it would be adding 2 each time. And that adding 2, that is this number right here. That's what we're increasing by each time. We've got 1 2, we've got 2 2s, we've got 3 2s, and so on. That number is in front of the n. So if you know that trick, that's going to help you on future examples. Okay, the next one. We need to think, this is the first term, this is the second term, this is the third term, the fourth term, the fifth term, the sixth term. So that's our input number. How can I input 1 and get out -1? I'm going to input 2 and get out 2.
You could do the -1 to the n.
Okay, so I'm going to start there. I'm going to say -1 to the n. So if I plug in 4, do I get out 4? Does that work? So there's more to it. That works for the negative and positive. So what do I still need to do? We need to multiply the answer by 4, or multiply the answer by n. So we've got a sub n equals n multiplied by -1 to the n. Some of this is trial and error. I'm going to give you tips, but a lot of it is trial and error. The next one. We've got first term, second term, third term, fourth term, fifth term. Who's talking? Somebody. Okay. N to the third. So if I plug in the fourth term and do that to the third, does that work? The fifth term to the third, does that work? She said n to the third. Does that work? So I think she just kind of looked here and said, ooh, each of those is the third power. Okay, I'm going to stop talking for a moment. I want you to kind of like think for yourself. Try something. See what you come up with. And then I'll go over it. How those numbers are. I've seen these numbers before. How have I seen them? you seen these numbers before? What's special about 1, 2, 4, 8, 16, 32? They're all times by 2. They're all times by 2. They're all powers of 2. Good. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. When I make this list, this number is the variable. That is the number that is changing. The 2 stays the same, but the variable is the number that varies. That's the number that's changing. And that's where my n needs to go. But if I put in n, it's not exactly this one. It's like the one before it. That's what I need to have happen. I'm not talking very well. So our a sub n is not 2 to the n, because that gives us the bigger one. That gives us the number, the next term, yeah. So we need the previous one. So we're going to take that n, we're going to subtract 1 from it. So if I do 2 to the If I do 2 to the 2 minus 1, that's still 2 to the first. If I do 2 to the 3 minus 1, that's still 2 to the second. 2 to the 4 minus 1, that's giving me 2 to the third. And remember, 2 to the 1 minus 1, 2 to the 0, anything to the 0 power is 1. Anything to the 0 power is 1. So you start making a list and you're like, I know this pattern, but it needs to be one previous or something like that. Sometimes you might have n minus 1 or an n plus 1 or something else in the exponent. That might be something you have to play around with to figure out. All right, did you look at the next one yet? Have you seen these numbers before? We need the a sub n because we're writing an equation, not just the expression. Have you seen these numbers before?
Yeah.
We need the a sub n. That is for All right, so this is 1, this is 2, 3, 4, 5, and when you look at that, you're just taking the n and squaring it. Okay, how about the next one? Have you seen those numbers before? What kind of numbers are they? Odd. Yep, so I'm looking here and I'm saying, ooh, each time I'm adding 2. That is a constant. It's the same thing every single time. So I know that it's going to be 2n. That's a tip that I gave you already. I know it's going to be 2n, but 2n by itself doesn't work. If I do 2 times 1, or I do 2 times 2, or I do 2 times 3, or I do 2 times 4, that's not these numbers. How do I make it into those numbers? Every single one of them, right? So we do 2n minus 1, that's going to give us all of those numbers. What'd you do?
I made it n squared minus n minus 1. And I found that.
Let me try that. Can you tell me what it was again?
Yeah, a sub n
Oh, like this? Okay.
Oh, no, that was it. I just had fraction.
I'm FOILing it out and distributing my negative sign. What ends up happening after I multiply it out and distribute my negative sign?
It just doesn't.
So if you do have stuff like that, it's fine. I'm gonna have this answer. So if you simplify it, you'll still get this answer.
Okay.
Mhm.
I just wanted to make sure.
Yeah, no. Good job. All right. This one. Persevere a little bit. A little bit. Try something. And if you're completely like, I need a break, mental break on that one, then try the last one. Come back to the fraction. Oh, and if you can get it and not tell your neighbor, I'll give you a treat. Your choice. Tons of treats up here. The fraction one, not the box. The fraction. If you tell your friend, neither of you gets the treat. So just saying. Very clever. Go get a treat.
Man, tough decision. Yeah, that was same. Oh, man.
I won't help.
You can help him with me.
I'll just look. I'm not gonna look at it.
You are close. You are really close.
I think I
One more moment. Everybody else for me to chat. So mad. So close.
Seriously?
You have half a treat.
Half a treat.
Okay, let's talk about it.
Wait, no.
Yeah. When you have fractions, here's a tip. When you have fractions,
They can be simplified.
well, yeah, that too, but even before that, when you have fractions, sometimes it is way easier to look at all the numerators and all the denominators and not look at as a fraction. Look at the numerators. Look at the denominators. And then compare that to 1, 2, 3, 4, 5. Does anybody notice, I know some of you do, do you notice a pattern in the numerators? Kind of. So there's two numbers in a row.
Almost was a 9. I'm just kidding, 3.
They're all multiples of 3.
Yeah.
Something's throwing off this pattern, because I have like, this is 3, that is 3 squared, that is 3 to the 4th, and that's 3 to the 5th, but that one's throwing it off. Why is that throwing it off? Because it was a reduced fraction. So if I actually unreduce it, if I take that 9 over 2, and I make that into 27 over 6, now my pattern's a little bit more obvious. So on the top, we've got powers of 3. And then on the bottom, we've got 2 times the number. So look, when you've got fractions, look at the denominator and the numerator separate. Check to see maybe something was reduced and you have to unreduce it. All right, last one. Last one's a lot easier. Did you have time to look at the last one already? Yeah. We have a common difference. What are we doing each time? Subtracting 3 each time. So if you are doing the same thing each time, that means there's going to be like a minus 3n. So from there, I'm going to try numbers. I'm going to do negative 3 times 1. I'm going to do negative 3 times 2, because that's my term number. Negative 3 times 3. But that's not the number that's sitting there. How can I take negative 3 and make it into minus 1? How can I take negative 6 and make it in, add 2 every single time, right? So we just do that to our formula.
If it's going down or going up, by the same number every time it's done, it's going to be good.
It will be multiplied by n. And that is because it's like on a graph, it's linear, and that's our slope. Because that's the same amount that we are adding each time. Okay, the last section, it has a different way of writing formulas. It's called recursive. And recursive is where you can't just pick any term and find the answer. Like I can't just find the 20th term. In order to find the 20th term, I have to know the 19th term. Recursive, you have to go like back a term, just back a term. Or if you know the previous term, you can find the next term. So if I know the 20th term, I can find the 21st. But I can't just skip to the 50th term. I would have to find every single term in between to get there. So this is a recursive formula. And a sub 1 is 15. So they've told us which term is 15.
So what?
What's that mean?
First one.
The first term is 15. So here's a formula that tells us how to get the next term. So it says a sub k plus 1. That means a sub the first term plus another.
So 18, the second one. This the extra 20.
I'm showing how to use this symbolism to decipher and find more stuff. Yeah.
Why is A?
K is the previous term. And I only know the first term. So when I plug in 1, I'm now going to find the second term. Over here, a sub k, same thing of right there. A sub k, that's going to be a sub 1. So this means take 15 and add 3. So a sub 2 is 18. My second term is 18. So to find the next term, we would take the previous term, which the previous term is now a sub 2, and add 1. So I'm going to find a sub 3. Using the symbolism, the formula, I'm going to do a sub 2 plus 3. I'm going to take the previous term, 18, and add 3. So I get 21. Once you've done a couple of those, then you should be able to figure out the rest of the numbers. So we've got 15, 18, 21,